Right,
This
so let us
conference will now be
start this
recorded.
session. So we have been discussing things with respect to the I2C communication protocol in the previous class. So we will continue with the same. We finished it partially. We couldn't finish it in the previous class. So we did the initialization of the I2C block with respect to the PIC microcontroller. We still have to do the initialization with respect to the RTC, and then we have to establish the communication between the two chips which are available on the same board. So whatever procedure we noted in the previous class, we are going to follow the same while achieving. We will be taking the same. So let me just open this. Okay. So we started with the initialization. We finished the initialization of the I2C block with respect to our microcontroller. So here in the I2C communication protocol, our microcontroller supports I2C communication. And to have that I2C communication protocol achieved, we are going to make use of 6 registers in total. So two of them are control registers, but another one is a status register. One is a buffer register, one more is a shift register, and the other one is address register. So we configured the two control registers and one status register. The buffer register is the one we use to have the data return whenever you want to transmit the data. And if you are trying to receive any data, whatever data is received is into this buffer register. We just have to read it from the buffer register. Then shift register, as you know, you cannot directly perform the operation on shift register. First, whatever data is written, it is first returned to the buffer register. Then it goes to the shift register. Then data gets transmitted bit by bit. Similarly, if you have to read bit by bit from the particular pin of a microcontroller, data will be received to the shift register. From the shift register, it is received to the buffer register. And from the buffer register, we just have to read the data. Then this address register will actually have the 7 bits of unique address with respect to the microcontroller, and that unique address will be useful only when the microcontroller is acting as a slave. Now, because microcontroller is acting as a master, can you tell me how this SSP ADD register is acting as? So when microcontroller is acting as a master, yes. So this is acting as a baud rate generator. So this SSP address register is going to be used for the baud rates generation. Then we configured the 3 registers, the status register, one control register and another control register. We also wrote the formula to calculate the baud rate. So the RTC works with a baud rate of 100K. So that we set it with the help of a formula. We selected a master, and using this formula, we calculated the value to be returned to the SSP address register for achieving a baud rate of 100K. And for every minute functionalities we are going to perform, we have some small functions written. So first, in order to wait till the bus gets idle, we have a function called I2C wait for idle. So whenever I have to perform any operation, I'm going to wait till the bus gets idle. So while r slash not of w bit, if you are going to OR with the 5 bits of the SSB contour until it falls down to 0. So I have to say that the bus has been in the busy state. The moment it falls down to 0, the bus goes to the idle state. So I'm going to wait till the bus gets idle with the help of a function call, that is I2C wait for idle. Now whenever I want to start the communication, I have to transmit a start bit. So to transmit the start bit, SEN has to be returned with the value 1. But every time before I make any operation, I make sure the bus has been idle. So I2C start function will first check if the bus has been idle, else it will wait till the bus gets idle, and SEN return with the value 1 will transmit a start bit. Similarly, we have repeat start. So where you have to wait till the bus gets idle, and RSEN should be returned with the value 1. Now, actually, the earlier versions of the PICSIM lab board, whatever PIC microcontroller it had, it was not supporting repeat start. So, in that case, you had to stop and then start again. But in all of our microcontrollers, the PICSIM lab board, whatever we are using, the versions above 8, so it supports repeat start, and that is why I have I2C wait for idle and RSCN return with the value 1. Then we have I2C stop. So in that case, I have to wait till the bus gets idle, and having PEN return with the value 1 is going to stop the communication. So these are the very minute functions which are used to achieve the communication. Now, whenever I want to read, okay, with the help of the I2C block, I'm going to call I2C read function. Whenever I want to write, I'm going to call I2C write function. So I2C write function will be called by passing the data to the return. So I have to wait till the bus gets idle, and whatever data to be returned, it is returned to the buffer register. From the buffer register, data is returned to the shift register. From the shift register, data will be transmitted bit by bit. And ACK stat is the bit which will tell me whether the acknowledgement from the other person, whoever is receiving, is received or not. So, for example, if master is writing, slave has to give the acknowledgement saying that it has received the data. Now, this bit is going to tell whether the slave has given the acknowledgement or not. So 0 was representing acknowledge received, 1 was representing acknowledgement not received. So we wanted to give 1 as success and 0 as failure. So we are returning not. Then whenever we have to read the data, we call I2C read function. So this function gives me the character whatever is read. So I have to first wait till the bus gets idle, and I have to enable the reception. Now, again, I have to wait till the bus gets idle, because there must have been data transmission done from the transmitter, and maybe the receiver is still receiving the data. So I have to wait till the bus gets idle. Now, once the bus gets idle, it's a confirmation that I have got the data received. So I'm just going to collect the data from the buffer register. Now, whoever is reading the function, so he is going to tell whether the acknowledgement is required or not. Okay. So if it is 1, acknowledgement is not required. If it is 0, acknowledgement is required. Now, accordingly, I'm going to update ACKDT, which is the one which tells whether the acknowledgement should be sent or not. So ACKN is returned with the value 1. Then whatever data is collected from the buffer register, I'm going to return that data. Any doubts in the initialization of I2C block of your microcontroller? Any doubts? Okay. So that was the first initialization. So init I2C with 100K being the baud rate. Now we are done with the initialization of the I2C block of our microcontroller. What else are we left with? What else are we left with? So this one is the initialization of I2C of the microcontroller. Okay, so this is the initialization of I2C of the microcontroller. I would say I2C block of the microcontroller. The next we have to do is the initialization of the RTC. And the initialization of the RTC should also be done, you being on the microcontroller. The RTC is a separate chip. It is just used to calculate the running time. So you have to do the initialization of the RTC as well, being in your microcontroller. So I'm going to call a function called init ds1307. So DS1307 is the name of the RTC block, the chip, the name of the RTC. So it is DS1307. So initialization of RTC should be done to the init function call. So I'm calling init DS1307 for the initialization of the RTC. Now, to do the initialization of this RTC, what should I refer? Do you think it is okay for me to refer the data sheet of the PIC microcontroller? Is it okay if I read the data sheet of this? No. I have to refer the data sheet of the RTC. So let me take you to the data sheet of the RTC. So RTC's name is DS1307. So I'm going to open this. Now this is a small technical document. It is just of 15 pages. So now whenever you get enough time, you can make sure to give it a try. Like you can try reading it for once. Now I will just highlight whatever is required for our operation. Okay. So what we are trying to achieve is from the RTC, I have to read the number of seconds, number of minutes, number of hours, and I have to get it displayed on the CLCD. Okay. So we are going to do the initialization of the RTC. Now let me, like as I said, I'm going to highlight only the required features of the RTC. So to start with, the name of the chip number of the RTC is DS1307. So that's a serial real-time clock. So RTC stands for real-time clock. It's a serial real-time clock. Means if you have to do any communication with respect to the RTC, whether you want to read or you want to write, you have to do it serially. So it doesn't support parallel communication. RTC is a serial communicating device, and whatever is written in the RTC, it is in the full binary coded decimal. Okay. So RTC is actually a low power device where all the data is written in the form of BCD form, that is binary coded decimal. Now what and all it has is, it has the information regarding clock or calendar, plus there is also a 56 bytes of NVSRAM. So there is a 56 bytes of SRAM available on the RTC as well. Next, whatever address or data you want to give to the RTC, it is transferred serially through I2C bidirectional bus. Okay. So if you have to communicate with this RTC, the only way is you have to make use of I2C communication protocol, and you have to involve a bidirectional bus. Now what and all it contains is the clock information, calendar information will be provided, such as seconds, minutes, hours, day, date, month, and year information. So every information is available on your RTC. Okay. The end of the month date is automatically adjusted for the months with fewer than 31 days. For example, there are some months which has 30 days. There's a month which has 28 days. So accordingly, the adjustments will be made by the RTC itself. The DS1307 does its adjustment by itself, and there is also a correction which is made at the leap year. Apart from that, the clock can either operate in 24-hour format or it can operate in 12-hour format. With, for example, there is a 12-hour format, there has to be a AM or a PM indicator. So these are the things with respect to the RTC, and the DS1307 has built-in power sense circuit that detects the power failure and automatically switches to the battery supply. So these are the features of the RTC which communicates with I2C communication protocol. Okay. So this is like the basic information. As I said, if you get enough time, you can go through this for once. It is not at all lengthier data sheet. Now let me jump to the very required information. So first information I take is, it's a low power device, and every data in the RTC is written in what format? Every data written in RTC is in what format? Yes, it is in the BCD format. So whatever is written in the RTC, it is in the BCD format. Now let us scroll down and move to the initialization part, because that's the one we have to be focusing about. So let us directly jump to that. So I have to do certain settings to do the initialization of the RTC. In fact, the initialization of RTC is a very simple task. Okay. So let us first see this. Okay. Here under clock and calendar, let me read it for you. So meanwhile, if you want, you can read it from your side as well. Now, the time and calendar information is obtained by reading the appropriate register bytes. Okay. So if you want to know any information regarding the time or the calendar, there are corresponding registers who store that value. You just have to read that register's value. Okay. So the time and the calendar information should be obtained by reading some appropriate registers which are available on the RTC. Now table 2 shows the RTC register. So here I have a table which represents the registers of the RTC. I will get back to it in some time. Let us see this. The time and the calendar are set or initialized by writing the appropriate register bytes. Okay, so for example, whatever time or calendar you want to set or you want to initialize, you have to write it to those register bytes itself. Okay, and as we already know, the contents of the time and calendar registers are in the BCD format. Every data return in the registers are in the BCD format, and it is talking about calendar mode. It's like the day of the week register increments at midnight. Values that corresponds to the day of the week are user defined but must be sequential. So I'm not focusing on this because my focus is just to read the time from the RTC and get it displayed. Now, illogical time and date entries leads to an undefined behavior. Now, when you are trying to set the time of your own, you have to write some values to the registers. Now, while the data is returned to the registers, you cannot give any illogical time. So, you cannot give time as 35 hours, 45 hours and all. You cannot give the date as 43rd of October or 59th of December, something like that. It is not allowed. All of that is going to lead to an undefined behavior. Now, the most important point. Bit number 7 of register 0 is the clock halt bit. When this bit is set to 1, the oscillator is disabled. When cleared to 0, the oscillator is enabled. So this is the only thing you have to do. Bit number 7 of register 0 is called as clock halt bit. And whenever this bit is returned with the value 1, oscillator is disabled. And if this is returned with the value 0, oscillator is enabled. Now please note that the initial power on state of all registers are not defined. So you don't know what is there in the registers when the device has just been powered on. Hence, it is important to enable the oscillator during the initial configuration. So I have to do this. I have to make CH bit with the value 0. So I don't know what are the states of the registers are, and CH by default will be disabled. So what you have to do as a part of initialization is you just have to write CH with the value 0. The moment CH is written with the value 0, the initialization of the RTC is done. Now, there is a register called register 0. So this one is the register 0. That register is available in the address 0x00. So it has 8 bits in total, starting from bit number 7 to bit number 0. Bit number 7 always represents CH. Bit number 6 to bit number 0 are used to store number of seconds. Okay. There is a register at the address 0x00 which is used to store the number of seconds. But number of seconds will be stored in only the 7 bits. The most significant bit is called as CH bit. It's a clock halt bit. Now what should I write to CH? To do the initialization of RTC, what should I write to CH? Yes, CH has to be written with the value 0. That is what it says. CH should be written with the value 0. Now, How to write CH with the value 0? It's the most significant bit of the register in the address 0x00. Okay, it's the most significant bit of the register which is available in the address 0x00. Now, how do you think I can write this value? So, how do you think I will be able to write 0 to CH? Now, where are you running your program? Whatever program we have been writing, where is it getting executed? It's getting executed on the microcontroller. Now, you being on the microcontroller, you have to write the first bit, the MSB bit of the register 0x00 with the value 0. Okay, so I have to write the first bit with the value 0. So whatever register I have got, I should have it written with the value 0. And please remember, you have written your program on your microcontroller. So it's your microcontroller who is going to have the data written. Okay. Now, so first of all, whenever I have to write it with 0x00, so assume I write something like this. Whenever I want to write to the RTC, okay, so I'm going to call a function ds1307 write. So ds1307, that's the name of the IC. So write. Okay, so whenever I have to write to the RTC, so I'm going to call ds1307 write function. Okay, so first I have to tell what to be returned. Okay, I have to tell what to be returned, and I also have to tell in what address the data has to be written. Can you see my screen? Okay. I'm sorry, I don't know what was the issue. So whenever I want to write to the RTC, I call the function ds1307 write, and whatever I have to write, first I have to tell in what address I have to write and what value should I write. Okay. Now, in what address should I have my data written? In what address should I have my data written? In the address 0x00. So I'm going to call ds1307 write function. The address is 0x00. Now let's say I pass 0 as the value to be written. Now do you think having 0 returned to the address 0x00 is right? Do you think having 0 return? Okay, 0, okay, fine. So if not 0, make all 8 bits as 0? Yes. So if I write 0 here, so its binary representation is 0, 0, 0, 0, 0, 0, 0, 0. Now what happens is I end up writing 0 to every bit. Actually, if you see the register in the address 0x00, only first bit corresponds to CH. Rest all other bits are used to store number of seconds. Now, if I write 0, don't you think number of seconds will get modified to 0? Don't you think number of seconds modified will get, yes. So, I have to write only CH with the value 0. How will you write only CH with the value 0? Okay, register and with 0x7F, that is right. But what do you know what is stored in that register as of now? Do you know what is stored in that register? No. So first I have to know what is stored in the register. Okay. So I have to know what is stored in the register. Okay. So we have to know what is stored in the register. Now whenever I have to know what is stored in the register, I have to read that register, correct? So to know what is stored in that register, I have to read the register. Now, whenever I have to read the value from the register, I'm going to call a function that is ds1307 read function. Okay, ds1307, the read function. Now, this DS1307 read function takes the address from which the read has to happen. Okay. And once the read is done, it is going to return me the value, whatever is inside that address. So it returns some 1 byte value. Okay. Assume it is unsigned character. Okay. So unsigned character is the return type. So whenever I have to read from the RTC, I'm going to call DS1307 read function. Now, from what address should I read? From which address should I read? From the address 0x00. So I call DS1307 read function by passing the address 0x00. Now, whatever is stored in the address 0x00 will be returned by DS1307 read function, and I'm going to collect into a variable called dummy. Okay. Now, assume this variable dummy has something like, so dummy has something like xxxx. I don't know what is it, xxxx. I just I'm sorry. I just want the first bit to be made 1. Okay. I just want the first bit to be made 1. So whatever it is, it doesn't matter. Sorry, yes, 0. I just want the first bit to be made 0. Can you tell me how to make the first bit 0? Make MSB 0. So how will I make MSB as 0? Yes, and with 0x7f. So I write dummy and with 0x7f. Okay. So that I will store back to the variable called dummy itself. Okay. So first I'm going to read from the address, store it into a variable called dummy. So I have to make MSB bit a 0. Now I have made MSB bit a 0. So it's like 0 xxxx xxxx. Okay, I don't know what the other bits has, so I'm least bothered about it. I just want to make the first bit as 0. I have made it. Now what should I write to the address 0x00 once I make the change? Yes, I have to write dummy. So now in the address 0x00, initially I had something like this. Now I have this return. Okay, so this is returned to the address 0x00. Now what happens in that case is only CH is made 0. Rest all of the bits will be retained as it is. Correct? So in this case, CH is made 0 and rest of the bits are ones. I mean rest of the bits are retained as it is. Correct? So that is the initialization of the RTC. The initialization of the RTC is you just have to make CH with the value 0, and CH is the MSB bit of the register available in the address 0x00. So you can see we have done the same. So dummy is returned with read DS1307 second register. So second register is the address 0x00. Then dummy and with 0x07 will make MSB as 1. Okay. Sorry, MSB as 0. So that data I'm going to write to the DS1307 calling the function write DS1307. So address is 0x00. Dummy will have MSB returned with the value 0. So in that case, CH is returned with the value 0. Now that oscillator is enabled, so it can calculate the time accordingly. So that's the initialization of the RTC. Understood this? Okay. Now we just called the function DS1307 read DS1307 write function. Now how is this actually happening? Can you explain the read function? I'm just calling the DS1307 read function and I'm specifying the address from where the read operation should happen. So from that address, whatever is read, I'm collecting it into a variable called dummy. Okay. So, and from that, I'm changing the MSB and having the same data returned to the RTC with the function DS1307 write. As of now, I have not elaborated DS1307 read and DS1307 write. So I'm just telling I will call the function to read from the address and call the function to write to that address. Okay. Now, being in the microcontroller, okay, so I have to read a value. Okay, I have to read, I would say first write. I have to write a value to the RTC. Correct? So being in the microcontroller, I have to write a value to the RTC. So which function will I call? Which function will I call? Being in the RTC, sorry, being on the microcontroller to have the data returned to the RTC. Which function will I call? So we will call the function DS1307 write function. Okay. So this is the name DS1307 write function. Okay. So I call DS1307 write function by passing the address and the value to be returned. Okay. Now, I am going to the RTC to perform the write operation. So don't you think the communication should happen between the two chips now? So this is your microcontroller. Okay. And this is your RTC. So your microcontroller should go to the RTC and it should write some value. Okay. So microcontroller and RTC should communicate with each other right now. Microcontroller should go to the RTC. Now, can you tell me what are the steps to be followed? What are the steps to be followed when microcontroller should go to the RTC and have the data return? What are the steps to be followed? So return type of the function is void DS1307 write function. Okay, and it is collecting address where the data has to be written and the data which has to be written. Okay, so when I have to establish the communication, microcontroller should go to the RTC and it has to establish the communication. What is the very first step? We are going to follow this. The very first step is I have to check if the bus has been free or not. So how will I check if the bus has been free or not? How will I check if the bus has been free or not? We just wrote a function. Do you remember that? Yes, DA line is one, correct, but we wrote a function, right? So there is a function called I2C wait for idle, correct? So I'll call the function I2C wait for idle. This is to check if the bus is busy. In fact, this is going to wait till the bus gets idle. Okay, wait till bus gets idle, correct? So I2C wait for idle function checks if the bus is being busy. It is going to wait till the bus gets idle. Next, after I make sure the bus has been idle, what is the next step? I have to transmit a start bit. So how do I transmit a start bit? I have a function for that again. So the function name is I2C start. Okay. So I2C start, this is to transmit a start bit. Now once the start bit is transmitted, you have seek the attention of the receiver. What should be the next step? What should be the next step? What should your microcontroller do? Yes, it has to transmit the unique address. Transmit the unique address. Do you transmit only the unique address? Do you transmit only the unique address? And also the intention. Okay. So whether you are going for the purpose of reading or for the purpose of writing. You have to transmit the unique address, also the intention. Now, if I have to transmit, means what does it represent, read or write? What does it represent if I have to transmit, write? So I call I2C write function, correct? So I'm going to call I2C write function. So I have to actually transmit the unique address, also the intention. Now, whose unique address should the microcontroller transmit? Whose unique address? Yes, it's the unique address of the RTC. Transmit the unique address of RTC plus the intention. Now, do you know what is the unique address of the RTC? Do you know what is the unique address? No, you have not known the unique address of the RTC yet. So that you are going to identify on your data sheet, the data sheet of the RTC. So let me take you to that unique address directly. Okay. Yeah. So you can see here, slave receive mode, that is your RTC's receive mode. The slave address byte is the first byte received after the master generates the start bit. Okay. Once the master generates the start bit, what you receive is the slave address. Now the slave address byte contains 7 bits of DS1307 address, which is 1101,000. What is the 7-bit unique address of the RTC? 7-bit unique address of the RTC. I'll make a note here. 7-bit unique address of RTC. Okay. So 7-bit unique address of the RTC is 1101,000. 1101,000. Now I have to write the intention. So the 8th bit should be the intention, followed by the direction bit r/naught of W, which for a write is 0. So what is the intention bit for write? For write, it has to be 0. For read, it has to be 1. Okay. Now, can you tell me what should be the value I should specify that I'm going to write? So what should be the unique address for write purpose? The unique address should be 1101,000, and for the read it has to be 1101,0001. Correct? Do you agree with this? Okay. So for the write it is 1101,000. For the write read it is 1101,001. So can you tell me the hexadecimal equivalent? Okay, so it's 0xD0, and for read it is 0xD1. Okay. Now tell me, what should I pass to the I2C read function? I want to transmit the unique address, and this time I'm going is for the purpose of write. Okay. This time I'm going is for the purpose of write. So what should I write to the RTC now? 0xD0. Okay. So that is for the purpose of write. Now, when I have said the RTC that I'm going to write, RTC has several registers. If you see here, okay, I have several registers. SSP ADD acts as address for the slave, need to set. No, SSP ADD acts as a 7-bit address register if your microcontroller is configured as a slave. Now we have configured our microcontroller as a master. So SSP ADD is acting as a baud rate generator. Okay. Now, if you can see, I have multiple registers in my RTC. I have a register in the address 0x00. I have a register in the address 0x01, 0x02, 0x03. So I have registers available in different addresses. Now, before I write, Don't you think I should tell in which address I want to perform the write operation? I have to specify. Actually, in what address I should specify the write operation? In what address should I specify the write operation now? So whatever address I have specified here, okay, whatever address, as of now I wanted to write into the address 0x00, that will be collected by the address here. So 0x00 and data will be 0xxx. I don't know what it is. Okay. Now when you say your RTC, that you are going to the RTC for the purpose of writing, your RTC will be expecting in what address you may write. So you are going to transmit the address where the data has to be written. So transmit the address where data has to be written. Correct? So for that, I'm going to call a function I2C write and let's say address. So whatever address here it is, so that address I'm going to pass. Okay. So see, first I have to wait till the bus gets idle. I have to transmit a start bit. Everything I'm following is according to this. So first check if the bus has been free, start bit, unique address along with intention. So acknowledgement is received. Now master has to transmit the address of the second register. So here we did it for the purpose of reading, but here master is going to write the data to the RTC. So master should transmit the address of the second register. To transmit the address of the second register, I call I2C write function and I pass the address wherever the data has to be written. I then write the data to be transmitted. Okay, so transmit the data to be returned to the register. Okay, so I'm going to transmit the data to be returned to the specified register, I would say, to the specified register. Okay, so again I call I2C write function by passing the data whatever I have to write. Now once I'm done writing the data, what should I do? What is the last step? What should be the last step? Once I'm done transmitting the data, once I'm done writing, so I have to stop. So I have to transmit a stop bit. Now to transmit a stop bit, I have a function I2C stop. Okay, so this is the function. So I2C start here. So this is DS1307 write function. I wait till the I wait till the bus gets idle. I then transmit a start bit. I transmit the unique address along with the intention. I then specify in what address the data has to be written. Then I'm going to specify in what data should be written, and I'm going to stop the communication. So that is DS1307 write. Whenever you want to write to the RTC, you being the microcontroller, if you want to write any data to the RTC, you call DS1307 write function by specifying the address and the data. And this is how the data is returned to the RTC. Understood this? This is DS1307 write function. The same, wait for idle, start. Slave write is representing 0xD0. Then whatever address you have got, you transmit the address. Whatever data you have got, the data is written. I2C stop. Understood this? Any doubt, guys, in this? Okay. You can note this function. The next we have got is DS1307 read function. Acknowledgement you said is a must, correct? So when you're calling the I2C write function, so I'm passing whatever data is written. Now, once the write function is called with the help of I2C write function, if you see, okay, in the I2C write function, see here, whenever I'm writing the data to the RTC, so especially the slave address, I don't have an option. Always an acknowledgement will be collected. So you can receive that acknowledgement and you can confirm whether the acknowledgement has been received or not. So as of now, I am not confirming that. Okay. But obviously, when you call the function, whenever you try writing the data, once the data is written, it always collects the acknowledgement from the RTC. So if you want, you can collect that return value. If same write function, then it doesn't get misunderstood with 0x001 as unique address and no. See, write function is the one which just writes to the RTC. So what I2C write function does is, whatever you specify, it will be returned to the buffer register. From the buffer register, it is returned to the shift register and data gets transmitted bit by bit. So that is I2C write. Now what should be returned? You write to the I2C write function. Now once you said what to be written, you also have to tell where you have to write. So that is again I2C write function. Okay, fine. Note this down, we'll proceed. Okay, there's a doubt. But in the I2C write function, we are collecting only data, right? And here we are using the same function to pass address also. See, I2C write function is used to write the data to the RTC. So whenever you want to transmit anything to the RTC, you call I2C write function being on your microcontroller. Now, all of this you don't have to write it in DS1307 write function itself. You can have it return independently also. So we are just grouping under DS1307 write. Now first I have to transmit the unique address. Then I have to transmit the address where the data has to be written. Then I have to transmit the data to be written. So everywhere I'm transmitting with the help of I2C block of my microcontroller. So I am calling I2C write function. Yes, so whether it is address or data, you are trying to write to the RTC. So you're transmitting to the RTC. So that is why we call I2C write function. Okay. Now, next is I have to read from the RTC. So whenever I have to read from the RTC, I'm going to call the function DS1307 read. So the function returns a character. So I say unsigned character. The function's name is DS1307 read, and it collects the address from which the data has to be read. Okay. Now, you being the microcontroller are going to the RTC to perform the read operation. Okay. You're going to the RTC to perform the read operation. So what will be the very first step? What will be the very first step whenever you have to read from the RTC? Come on. So we are going to follow this, whatever we wrote it here. So first I have to check if the bus has been idle or not. So I'm going to do the same. So I'm going to check if the bus has been idle. I will wait, in fact, to get the bus in the idle state. Now what is the next step? What will be the next step if I have to read from the RTC? I have to start the communication by transmitting a start bit. Then what should be the next thing? I should transmit the unique address of the RTC and my intention. Previously, my intention was write, and this time my intention is read. Okay. So first my intention will be write, then my intention will happen to be read. But actually what happens is, whatever you specify the intention here, that is for the next step. For example, I have to first tell the RTC that from this address I am going to read the data, right? So first I have to, let me say, transmit unique address, of RTC plus the intention. Now, I2C read is quite challenging. Please pay attention here. I have to transmit the unique address of the RTC plus the intention. What should be the next step? What should be the next step? Come on. What should be the next step? I have to give the address from which you want to perform the read operation, right? I have to transmit the address. Okay, I have to transmit the address from where the data has to be read. Correct? I have to transmit the address from where the data has to be read. Now, if I directly say the intention as read here, okay, if I directly say the intention as read here, what happens is the RTC will try giving out the data. Okay, so directly RTC will give out the data. So first it is my duty to tell how or from which address I'm going to perform the read operation. So I have to transmit the data. Now my next step is to transmit the data. So my intention here has to be write. Okay. My next step is transmitting So I should write to the RTC. So I call I2C write function. Okay, I call I2C write function by passing the write intention, that is 0xD0. Okay, so I'm transmitting the unique address along with the intention. I'm not writing the intention directly as read. First, I have to tell the RTC from which address I have to perform the read operation. So my next step is to transmit. You are transmitting. You are not expecting the data directly. My next step is to transmit the address from where the data has to be read. So my intention will be right here. Okay. Then I transmit the address from which the data has to be read. So I2C write function by passing the address. So whatever address I want to read it from. Okay. Then my intention is changing. Now I'm expecting the RTC to read. Okay. I'm expecting the RTC to read. So my intention is changing. I2C, let's say write function. I have to pass the unique address along with the intention of reading. Okay. I have to give the intention of reading. So this intention is read. I'll repeat this again. Please wait. Intention is read. And then I'm going to read by calling the I2C read function by passing 0 or 1 as an argument. So that I have to collect it into a variable called ch, okay, or whichever you need. I'm going to stop the communication, I2C stop. Then I have to return the ch value. Okay, so I have to return, I'm sorry. So I have to return the ch value. Okay, so I'm repeating this again. RTC register addresses are not of 7 bits. No, RTC registers address are of 8 bits only. Only unique address is of 7 bits. Okay, so I'm repeating this again, how the read operation is performed on the RTC. Okay, so first I'm calling I2C wait for idle function to check if the bus has been busy or not. So I'm actually, yeah, I'll explain it step by step with that note what we made. Give me a second. Okay. Now see. So first I'm going to wait till the bus gets idle, the very first step. Then I have to transmit a start bit. I have transmitted a start bit. Then I have to pass the unique address along with the intention. Okay. So I have to transmit the unique address along with the intention. So unique address is 11010000 and what is the intention? Now before I transmit the intention, you see the next step, master has to transmit the address of the second register. Okay, so master has to transmit the address from where the data has to be read. So my next operation is I'm going to transmit, which is nothing but write. So I have to tell the RTC I'm writing you something, I'm specifying you something. So it is I2C write. Okay, so my intention is right here, hence I'm passing 0xD0. So transmit the unique address, also the intention as right. And you now gave the address from which you want to perform the operation. So whether it is read or write, you haven't said. You are just telling I'm coming for the purpose of writing. Okay. If you want, actually I can add one more step here also. See, here also what I say is, I have to specify the write. Okay. I have to transmit the address first before I transmit the data to be returned. Now, whenever I want to transmit the address, I should call I2C write function. So my intention is writing. Then again, I have to write some data. I'm going to transmit. I have to write this step again, in fact. Okay. But my previous intention and this intention are the same. So we skipped it. Are you able to follow? Are you people getting this? Okay. So here also, whenever I have to read from the RTC, first I have to transmit the address from where the read operation should happen. So I want to transmit first. So my intention is writing. Now once I have transmitted the address, your RTC got to know from this address, microcontroller wants to do something. Now what is it? If it is write, you transmit the data directly, whatever it is to be returned. But if it is read, I have to change my intention. So I'm calling I2C write function. And in fact, when there is a change of intention, I should again start the communication by calling the function I2C repeat start. Okay. So this is when the intention is changed. So intention is changed. Okay. Now intention is read. Now your RTC got to know whatever address I have received previously, the microcontroller wants to read. So I call the I2C read function. I2C read function will collect the data from the buffer register. Actually, RTC is done transmitting the data. The data will be stored in the buffer register. From the buffer register, I store it into a variable called CH. And I'm going to stop the communication and return whatever I have collected inside CH. So that is I2C, that is read DS1307 function. So waiting till the bus gets idle, start condition, then my intention is right, I transmit the address. Then repeat start. My intention changed, I'm calling I2C read function by passing 0. I collect into a data. Then I2C stop and return. Where RTC transmit data to the buffer in the code. The moment you say this intention as read, okay, the moment you say the intention as read, now RTC knows from which address you want to perform the read operation. So what RTC does is, in the same bidirectional line, okay, it starts transmitting the data. So the moment read intention is known, it transmits the data. Bit by bit data first gets returned to the shift register, then to the buffer register. Now when I call I2C read function, whatever is stored in the buffer register, I collect it into a variable. So you can see here. So when I call I2C read function, okay, whatever is in the buffer register, you collect it into a variable called data. So that data gets received here and the same data is returned to the user back. So that data you collect it here. Understood? Okay. So that is I2C write function. So if you want, you can have this noted. So this is I2C read function. Okay. So 0 or 1, this is for the purpose of read from buffer register. Okay. Note this down, we'll continue. Okay, done. I2C read of 0, what does 0 stands for? So here when we are calling the read function, okay, so your master, so you being the master is going to the RTC for the purpose of reading. So whether the RTC needs the acknowledgement or not, so I'm going to decide it depending on the value being passed. So if 0 is transmitted, it is like I need the acknowledgement. Okay, if I2C read function is passed with 0, then acknowledgement is required. Okay, so accordingly the acknowledgement from the master will be given to the slave. Okay, fine. So that is the initialization, and after that I have the initialization of the CLCD. I don't think we need that explanation. Then I'm calling CLCD print function, and I'm passing DS1307 test on line 1 zeroth position. So on line 1 zeroth position, I'm having a message printed as DS1307 test. Now tell me, what and all should we be reading from the RTC to get the time displayed on the CLCD? What and all should we be reading? Hours, minutes, and seconds. So if you observe the data sheet of the RTC, let me show it up here. So I have multiple registers. The register in the address 0x00 is having the data regarding the number of seconds. The register in the address 0x01 is having the data regarding number of minutes. The register in the address 0x02 is having the data regarding number of hours. So I should read from these three addresses, right? Now, whenever I have to read, I'm calling the function get time clock register. So I have taken a clock register of size 3. I'm calling get time function by passing the clock register as an argument. Now get time function is collecting a pointer called clock register. Now clock register is of size 3. So that's a character array of size 3. Okay. Now I'm reading from the hover address. So hover address is 0x03. Sorry, I think 0x02. So 0x02 is the hover register. I want to read from the RTC. So I call read DS1307 and I pass 0x02 as an argument. So this function reads the data in the address 0x02 and gets it stored inside clock register of 0. Similarly, I call read DS1307 function by passing the minutes address. So minutes address is 0x01. So that is read and it is stored in clock register of 1. Clock register of 2 is stored with the second register's value. So I call read DS1307 by passing the second register's address, which is 0x00. So whatever is in the address 0x00, that is stored inside clock register of 2. So clock register array now has hours, minutes, and seconds stored. So clock register of 0 has hours, clock register of 1 has minutes, clock register of 2 has seconds. Correct? Any doubt in this? Okay. Now whatever you have read from the hour register, minutes register, second register, what type of data is it? Whatever is returned into this, what type of data is it? Is it an integer? So how are the data returned inside your RTC's registers? How are the data returned? Yes, in the BCD format. So whatever you have read here, the hours, minutes and seconds, they are in the BCD format. So BCD stands for binary coded decimal. Do you think I can print everything directly on the CLCD? Can I print BCD data directly on the CLCD? No. I have to convert it into individual characters before displaying. Now clock register of clock register of 0 has hours, clock register of 1 has minutes, clock register of 2 has seconds, which I have to convert it into individual characters. So hours can be of 2 digits, minutes can be of 2 digits, seconds can be of 2 digits. So I'm going to print it like this: hours, colon, minutes, colon, seconds. Now what I do is, I take an array, I first format this, then I will display it on the CLCD. So to have the data displayed, I'm calling display time function by passing clock register as an argument. Okay, so clock register has hours, minutes and seconds. Now coming to the display time function, I have taken clock register. Clock register of 0 has hours, clock register of 1 has minutes, clock register of 2 has seconds. Now I want to print 2 digits of hours, a colon, 2 digits of minutes, a colon, 2 digits of seconds. So total how many characters have I got to print? How many characters have I got to print? Totally 8 characters. And one more, I will take a null character. So I am taking a character array called time of size null. I will store this inside the time array and display it all together. Now what is clock register of 0 having? What is clock register of 0 having? Clock register of 0, is it having seconds? Clock register of 0 is having hours. Okay, so it has 2 digits of hours. Let's say the hours is now it's 8 o'clock. The hours is 8. So if you take it in a 24-hour format, it's 20, right? So hours is 20. Now I have to get the 20. I have to write it as 2 and 0 inside the time array. 2 as a character, 0 as a character. Now if you take the hour register here, you can see the first bit is always fixed to 0. Okay, the first bit is always fixed to 0. The second bit will have 12 or 24-hour format. So let me take it here. Okay, so first of all, hour register, it is in the address 0x02. So I'm done reading the data in the address 0x02. I have 8 bits inside it: bit 7, bit 6, bit 5, bit 4, bit 3, bit 2, bit 1 and bit 0. Okay. Now when it comes to the bit number 7, it is always fixed to 0. Bit number 6 will represent 12 or 24-hour format. Now let us take 24-hour format. Now how to represent it is in 24-hour format is, you can see here, the DS1307 can run in either 12 or 24-hour format. Bit number 6 of the hours registered is defined as 12-hour or 24-hour. When high, 12-hour mode is selected. So when high, 12-hour mode. So ours is 24 hours mode. So what do you think it has? Ours is 24 hours mode. Yes, it will have a 0. Okay. Now, in the 24-hour format, bit number 5 and bit number 4 represents the first digit of hour. Bit number 3 to bit number 0 represents the second digit of hour. Okay. So I can say bit number 5 to bit number 4, first digit of hour. So let me write here first digit of hour. So bit number 5 to bit number 4. Now from bit number 3, I have second digit of hour. Okay. So bit number 3 to bit number 5, I have second digit of hour. Now to get the first digit of hour, let's say the time is 23 hours. or let's say the time is 19 hours. Okay, so what will your hour register has is, first bit is 0, second bit is 24 hours, so it is 0. Bit number 5 and 4 is to represent first digit of hour. So first digit of hour is 1, so I will have 0 1 written here. Then bit number 3 to bit number 0 is to represent the second digit of hour, which is 9. So 1001 will be written. Okay. Now tell me how to get the first digit of hour. First digit of hour. How will you get the first digit of hour? Come on. How will you get the first digit of hour? So this data is already stored in clock register of 0. Okay. This is already stored in clock register of 0. How to get the first digit? How to get the first digit? I have already read it. It is already stored in clock register of 0. Right shift it for 4 times, then AND with 0x03. Okay. So after I right shift it for 4 times, let's say clock register of 0. Okay. Right shift it for 4 times. These 4 bits will come to the right. Correct. So I'm going to AND with 0x03. So AND with 0x03. So that gives me the first digit of hour, correct? Now how to make it a character? How to make it a character? Because on CLCD I can display only character. So now what I get is an integer. Yes, I have to write plus character 0. Now how to get the second digit of hour? Second digit of hour. How will you get that? Yes, I can directly AND it with 0x0, and I can add character 0 to it. So clock register of 0 and with 0x0, and you have to add a character 0 to it. Correct? So clock register, this will give me the first digit of hour. I will store it in time array of 0. Okay. And this will give me the second digit of hour. I will store it in time array of 1. So you can see here, time array of 0. This is time array of 1. So I first got 2 digits of hour return in the time array. Then time array of 2, I am storing as colon because I want to display colon. Then coming to the number of minutes. So number of minutes is already stored in the character array, clock register of size 1. So it also has 8 bits. If you see that, the first bit is always 0. The next 3 bits will have the first digit of minutes. Next 4 bits will have the second digit of minutes. Now assume number of minutes is 0, let's say 56. Number of minutes is 56. So first bit is always 0. Second, third, fourth. The next 3 bits will represent the first digit of minutes. So 1, 0 and 1. That is 5. Then 6. 1, sorry, 0, 1, 1, 0. So first bit is always 0. Next 3 bits represents the first digit of minutes. Next 4 bits represents the second digit of minutes. Did you get this? Are you following this? Now how to get the first digit of minute here? How to get the first digit of minute? Right shift it for 4 times and with 0x07. Correct. So plus 0. Then this already you know 0x0f you have to add plus 0. So that I am storing it time register of 3, time register of 4. Okay. Then time register of 5 will have a colon taken. Time register of 6, time register of 7 will have the seconds value. So clock register of 2 already has the number of seconds stored in the BCD format. I have to extract the first digit and the second digit. Then time register of 8, I'm terminating it with the null character. I'm calling CLCD print function by passing time on line to fourth position. So hours, minutes, seconds will be printed. Observe the output here. I'm going to build this. So meanwhile that is getting built, some functions, some implicit function calls are there. Okay, fine. It's a pretty lengthy code, so it takes a little more time comparatively. Okay, some functions are called. Okay, fine. So build has been successful and loading is completed. So let me load the hex file now. So file, load hex. Now I'll go to the I2C sources. Okay, DS1307, distribute, default, production, the hex file. Okay, so now RTC is not enabled yet on my board. If you can see here, the third DIP belongs to RTC. So if I have to choose RTC, my DIP has to be against it. So let me put it against it. Okay, I'm going to reset the board. Oh. One second. I have kept it against RTC. Okay, it has to be against RTC in fact. So I have reset it. Let me check for repeat start like this. Okay. So this is the first time I'm using this version of Pixim Lab. I'm not very sure. Okay. So can you see, like, let me reset the board. So it says 23 hours, 45 minutes, 59 seconds. Let me close this. Open the ID, the Pixim Lab again. Okay. Can you now see the perfect time? 20 hours, 44 minutes, 35 seconds. Okay. Now the problem with this version of Pixim Lab is, as of now, I'm using, if you see this, I'm using version 0.8.9 and it doesn't support repeat start. So for that, what did I do was, wherever I have called the repeat start function, I replaced it. So instead of RSE and return with the value 1, I stopped and start the communication again. So repeat start was a problem, which is why it was not working fine. Now you can see the proper time being running. Okay, so in your case also, if repeat start doesn't work, then you may have to do start and stop to see the output. I mean stop and start. Okay. And this completes the I2C communication protocol. Any doubts? How it exactly, have it correctly loading the exact standard time, we just on now, right? Yes. So it hardly takes a few of fraction of seconds only to do all the basic configurations and initializations. So once the oscillator is on, accordingly it takes the time. So it first it extracts the time whenever the host has been active. It extracts the time and then it counts accordingly. So once the oscillator is turned on, the exact time will be taken, and every read and write operation you have done is happening on fraction of seconds. So it did not take the complete time, in fact. So once your oscillator was turned on, it extracts the time from the PIC microcontroller. So there's an oscillator or a host device. Once RTC has been just initialized, it takes the number of minutes, number of seconds, and number of hours from whichever the source of time you have got in your system. From there, it continues to count the running time. As long as it is kept on, it continues to count the running time. Okay, and this is about RTC. Any doubts? And we are left with one last communication protocol, which is nothing but CAN. We don't have programming for CAN because we don't have a supporting tool for CAN to be used. So we don't have CAN protocol programming part, but it is a very important communication protocol. You at least have to know how the operations happen. So we will see the introduction and something detail associated to the CAN protocol in the next class. I hope the class has all been clear. Okay. So here is your QR. Please have your attendance marked and then quit the session. We'll continue the R2C communication, sorry, CAN protocol in the next class. What is I2C frame format means? Is it registered? We are not exactly transmitting a frame here in case of I2C. We are transmitting the data into the buffer register. If you want to look it as a frame, first you are going to check the bus idle condition. So that is not a frame, in fact. Then you transmit a start bit. Then you transmit the unique address along with intention. Then you transmit the data, whatever you want to transmit or read. So it will have the data, then a stop bit. So that's the frame altogether. Okay, fine. So thank you all. We'll continue tomorrow.